For this problem, we're going to use the formal definition of a derivative to find the derivative of f of x is equal to 5x squared plus 3x, and we must use the formal definition of a derivative for this problem. All right, so for this one, we remember that f prime of x is defined to be the limit as h approaches 0 of f of x plus h minus f of x all divided by h. All right, in this problem, that'll be the limit as h approaches 0 of okay, the second part's easiest, so let me write that out first. Minus 5x squared plus 3x, all divided by h. And then for the first part, everywhere I see an x, I replace by x plus h. So 5 times x plus h squared plus 3 times x plus h, all in brackets. Okay, so let's start simplifying. The limit as h approaches 0 of, on top I have 5x squared plus 10xh plus 5h squared. Then here I have plus 3x plus 3h. Over here I have minus 5x squared. And then I have another minus, so minus 3x, all divided by h. Okay, things start simplifying considerably on the next line. So this is equal to the limit as h approaches 0. And I notice that I have a 5x squared here, and I have a 3x's there. And so all that'll be left are these three terms, 10xh plus 5h squared plus 3h, all divided by h. Okay, now I still can't plug in 0 because of the h in the bottom. However, I can factor out the h on top. So limit as h goes to 0, and I can factor out an h on top. I have 10x plus 5h plus 3, all divided by h. And so the h's cancel, and so I have the limit as h approaches 0 of 10x plus 5h plus 3. Okay, now as I now let h go to 0. As h goes to 0, this middle term goes to 0. These two things don't change because h is going to 0. And so I get my answer as 10x plus 3. And so that is the derivative of the function f prime of x is equal to 10x plus 3. Later on in this course, we'll talk about how to get this more quickly. But for now, that is the way of finding the derivative using the formal definition of a derivative.